નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study the exercise 5.3. This is the exercise of standard 8 chapter number 5 data handling. So in previous class we have studied about a chance and probability, right? So now we know about the basic terms related to the probability. What are the terms? First is the random experiment, then outcomes, then events, and then probability. So here in this exercise we will study how we can implement this all the terms, how we can use all these terms. So the very first question, that is question number 1 of exercise 5.3, is list the outcomes you can see in this experiments. See, here we have given the experiment. First experiment we have given, that is A, that is spinning wheel. So this is the diagram of spinning wheel. You might have seen this type of spinning wheel in many places. Like might have seen in the television, you might have seen in the game. So this type of spinning wheel, how it works? See, there is an arrow. Currently, it is indicated at B. This point, which we can call at the center of the circle, this point is fixed, right? And we can rotate this spinning wheel so that this arrow does not change its place. It is fixed, but the words that we have write down will rotate around this center, and where it stops, that we cannot say. So this is a spinning wheel and this is an random experiment. So here we have to note down that what kind of outcomes we can get here. So see, outcomes, that means here what are the write down on the spinning wheel, the A, B, C and D. See, A is here two types, but still the arrow will stop either at A, either at B, either C or D. So these are the outcomes A, B, C and D. When we rotate this, we get out of this 4 outputs. So these 4 are the outcomes. Okay. Second thing is tossing two coins together. Tossing two coins together. Now we know that what are the outcomes when we toss a single coin, that are head and tail. But here two coins are there. So when we toss two coins together simultaneously, both will give the output. And what kind of output they can give? They can give first outcome as, suppose both has head and head, both has the output, suppose head. Second thing, we can think that the outcome may be on both the coin, it is tail. Third outcome, we can think that on the first coin it may be head, or on second coin it may be a tail. In the same way, fourth one, we can think that this output may be reversed, that on the first coin we get the tail and on the second we get the head. So these all are the possible outcomes we can get when we toss two coins together. Okay, so this is the question number 1, how we can find out the outcomes. Now question number 2, when a die is thrown, list the outcomes of an event of getting a prime number. Okay, so here we have to find out the first outcomes, then when we get a prime number. So on the die we know that there are 6 numbers on the 6 sides. So out of that, which number are the prime number? First prime number we get is 2, second prime number we get is 3, and third prime number we get is 5. See here, note down one thing, 1 is not a prime number, right? Because according to the definition of prime number, a number which has only 2 factors, the number itself and 1. There 2 factor must be there to have a prime number. So these 3 are the numbers which we get as a prime number, right? When we throw a die. So the second thing is we have to find out the outcomes that not a prime number. So as these three are the prime numbers, so whatever the left are the not a prime number. So 1, 4 and 6. These three are the outcomes which we can say they are not a prime number. Third one, a number greater than 5. Number greater than 5. So that there is only one number 6. That is greater than the 5. So this is the outcome. We can say a number greater than 5. Now fourth one is a number not greater than 5. So not greater than 5 means we have to take a number which is not greater than the 5. So how many numbers we get here? 1, 2, 3, 4. Now think about, can we take the 5? Yes, we can take the 5 because 5 is a number which is not greater than the 5. It is equal to the 5. Okay. Now the question number 3 is find the probability of the pointer stopping on D in question number 1a. So this is the question number 1a. And from here we have to find out the probability that a pointer stopping at D. So when we spin this spinning wheel, what is the probability that this point is stopped at D? Currently it is stopped at B. So what is the probability? See, first of all we have to find out how many outputs are there. See, first, second, third, fourth and fifth. Five places are there where this arrow can stop. So the total number of outcomes is 5 and required outcomes is what? D, and D is one time here only. So here 1, 2, 3, 4, 5 is the total output and required output is 1. So we can write down 1 upon 5 is the probability that pointer stopping at D. Understand? Okay, in the same way, B. In the B we have given that find out the probability of getting an S from a well shuffled deck of 52 playing cards. So you might play with the playing cards and you know that there are 52 cards. There are 4 types of cards and in all 4 the types one S is there. So how many S's are there in the well shuffled deck card? 4. And how much is the total cards? 52. So we can take 52 as the total outcomes. 52 as the total outcomes, and how many outcomes are there that we required? We required an S and 4 S are there. So 4 upon 52 will be the probability of getting an S. Here we can cut the common factor, that is 13 4s are 52. So here we can cut and we get the answer 1 upon 13, right? So this is the probability of getting an S from the well shuffled deck of 52 cards. Third probability we have to find out is probability of getting a red apple. So here we have given this diagram. We have to find out the getting a red apple. So first of all, how many outcomes are there? Count 1, 2, 3, 4, 5, 6 and 7. So 7 is the total outcomes we can get here. Now required outcomes. Required outcomes is what? Red apple. So see how many red apples are there? 1, 2, 3 and 4. So this is the 4 upon 7 is the probability of getting a red apple. Here you may have asked to find out the probability of getting a green apple. So probability of getting green apple, how we can calculate? Here also the total outputs are 7. So in the denominator we have to put the 7. Now count the how many green apples are there? 1, 2 and 3. So 3 upon 7. We can say that the probability of getting a green apple. So it is not necessary that you have asked to only find out the red apple, right? You may have asked to find out the probability of getting green apple. In the same way, you have also asked to find out the probability of getting yellow apple. So total is 7. Now count how many yellow apples are there? No, 0. 0 yellow apples are there. So 0 upon 7 is what? 0. So this is the probability that we can say that there is a no yellow apple in this diagram. So the probability of getting yellow apple is what? 0. This is an impossible event because there is no yellow apple is there. Okay. So in this way you have to think about how we can find out the probability. Right. Now let us see the question number 4. Question number 4 is numbers 1 to 10 are written on the 10 separate slips. One number on one slip. So 10 numbers we have to write, that is there is write down on the 10 different slips. Kept in a box, mixed well. One slip is chosen from the box without looking into it. What is the probability of getting number 6? So see here, how many total outputs we can, how many outcomes, total outcomes are 10. So here we can write down in the denominator 10 is there. And getting the number 6, now the required outcome is 6. So how many times 6 repeats in 1 to 10? Only one time. So 1 upon 10 will be the probability of getting a number 6. See, do not confuse here. Do not take here 6 upon 10 because it is said that getting a number 6. So we have not to write down 6 here. Whatever we put in the numerator, that means how many times the required outputs occurs or how many times the required output repeats. So 6 repeats or 6 occurs only one time in 1 to 10. That is why we have to put here 1. In the same way, now find the probability of getting a number less than 6. So the number less than 6. Here also the total output is 10. So here denominator we have to write down 10. Now think about number less than 6 means 1, 2, 3, 4 and 5. These 5 numbers are which are less than 6. So what are the required outcomes? 5. So here we have to write down 5. And when we cut the common factor, we get 1 upon 2. So this is the required probability, that is of getting a number less than 6. Now probability of getting a number greater than 6. So here also total outcomes are 10. Number greater than 6 means 7, 8, 9 and 10. 4. So 4 upon 10. So when we cut the common factor, 2 is the common factor, we get the output 2 upon 5. Right? So this is the probability of getting a number greater than 6. In the same way now, probability of getting one digit number. Here also the output is what? 10. Total outcomes is 10. One digit number. So into 1 to 10, 1 to 9 are the one digit number, while 10 there is 2 digit, 1 and 0. So 9 outputs we get, required outcomes are 9. So this is the probability of getting a one digit number, and that is 9 upon 10. Okay, so in this way we can calculate the outcomes, we can find out the probability, or how we can find out the probability which is not given, which terms is not given. So we can write down if the required outcome is not there, the probability of that event is 0. Right? So these all are, we can say, the event. Pointer stopping at D, that is an event. Right? In the same way, getting an S, that is an event. Getting a red apple, that is an event. So now this picture is, I think, now clear in your mind that what are the basic terms related to the probability, how we can find out the probability. Okay? So this is all about this lecture. Thank you.
Thank you for joining us.